Good afternoon, everyone, and welcome to the class. Okay, good to see all of you back, and good to see all of you in the same class. That's great. Okay, so in the previous class, as I already told you, we have finished your motion in 2 dimension. As such, we have finished your projectile wala part. In today's class, we will start with your relative motion part, and we will try to wind it up. After relative motion, we'll move on to your circular motion. So that is how we are going to go. So let us start your relative motion part. And as soon as I start relative motion, I want to ask you, what do you mean by relative motion? Is this a new topic that we are doing for the first time, or have we done it before? What do you mean by relative motion? The heading of the chapter is relative motion. The heading of the topic is relative motion. You might have heard a lot about relative motion, relative this, relative that. Is this something new that we are doing today, or we have done this before? Yes. Is this anything new that we are doing it now? Relative motion. Previously, we were not studying relative motion. Now we are getting into this new topic where we are studying relative motion. Is that so, or we have been studying relative motion before also? What do you think? I hope you can hear me, you can see me, and you can use the mic. Yes. So, is relative motion a new topic that we are doing? Is this a new one, or is this an old one? New one means yes, old one means no. New one or old one? New one. It is a new topic. Well done. No, it's not a new topic. It's already an old one. We have been studying relative motion from the very first day. If you remember, the first thing that I told you about rest and motion, and I told you that rest and motion are what type of terms? Rest and motion are relative terms. Do we remember this statement? Rest and motion are relative terms. This was the first statement that we studied when we started with your first class. Rest and motion are relative terms. And then I told you, what do you mean by relative terms? What do you mean by relative terms? What do you mean when I say rest and motion are relative terms? What do I mean by that? Yes? What do I mean when I say rest and motion are relative terms? I hope everyone is able to see me and everyone is following the class. Yes or no? Okay. Do
Yes,
you
sir.
do you remember we had said rest and motion are relative terms? What do you mean by this word relative then? We had discussed this term relative then, and I told you that. Remember this? Anyone? No one remembers? If anyone remembers, please tell me, what do you mean by relative terms? Rest and motion are relative terms. What do we mean by this? Do it fast, fast, fast. We are way behind the course schedule. Do it fast. Rest and motion are relative terms. What do you mean by this?
Means they both are interlinked. Rest and motion.
They are
Interlinked.
interlinked. No, that is no. That is not the meaning of the term relative. Anyone else? The term relative here does not mean that they are interlinked.
What depends on reference frame, sir.
Yes, they depend on reference frame. Rest and motion are relative term. That means they depend on reference frame. In some reference frame, we can see that an object is at rest, but in some other reference frame, the object might be looking in motion. That is why we say that rest and motion are relative terms. Now, up till now, what we were doing, we were studying motion or rest with respect to a fixed frame, which we probably did not talk much about because it was always the same. We were studying everything with respect to what frame, which frame? We were studying everything with respect to ground or earth. Whatever motion we studied up till now, we were studying it with respect to ground or earth. So whenever we said a car is moving with a velocity 5 meter per second or 10 meter per second, that velocity was given with respect to ground or earth. We did not specify it because there was no point of making it more lengthy and probably more confusing. It was with respect to what? So when we said that velocity of A is something, it actually meant velocity of A with respect to ground or with respect to earth. Do we understand this? So whenever we said anything, VA, that was velocity of A with respect to ground. Now, in this chapter of relative motion, obviously, there is no need to study it. There is no need to study it as a separate chapter, as a separate topic, because it is always there. Rest and motion are relative terms. We are always studying rest and motion with respect to a reference frame. Why it is given a separate name is because in this particular topic, in this particular class, what we are going to do is we are not going to study rest or motion from Earth's reference frame. We might be studying it from some other body's reference frame. Now the question arises, why we have to study the motion of any body with respect to some other body? What benefit we have? Well, the benefit is very simple. If I just give you an example, if I say that this is a bus, if I say that this is a bus which is moving with a uniform velocity v, now in this bus there is a boy who is playing with a ball. He is throwing the ball vertically upwards and the ball comes in his hands straight away. But at the same time, this bus is moving. Now, this is also a relatively simpler motion, not very typical one. So I'll give you one more example. Now I have two people who are trying to study the motion of this ball with which the boy is playing. One of these is standing on ground and watching the motion. The other one is in the bus and standing and studying the motion. How does the motion look like to each of the boys? To the boy here who is inside the bus, boy B, how does the motion of the ball look like? He's inside the bus is moving, and this boy is playing with the ball. He throws the ball vertically up, and the ball comes in his hand. So, what type of motion will he see? The boy who is in the bus, what type of motion will he see? I'm talking about the motion of the ball. Anyone? What will he see? The boy in the bus watching the red boy playing with the ball. He is throwing the ball up and the ball comes back in his hands. What type of motion will he see? Will he see a straight line motion or will he see something else? Tell me.
Straight line motion.
For him, the motion is straight line. The ball is going straight up and the ball is coming straight down. But now try to imagine what is the motion seen by him. How does the motion of this ball look like? Remember, the ball is with the boy inside the bus and the bus is moving. For him, the motion is not a straight line. In fact, the motion would be a parabola. Do we understand this? Because when he throws the ball up, with respect to ground frame, the ball is also moving forward and the bus is also moving forward. The ball is also going up, the ball is also moving forward. So for him, the motion will be a projectile motion, but for the boy inside the bus, the motion is still a straight line motion. So it becomes simpler for the boy in the bus to steady the motion. I hope I am making the point clear. I can take one more example to make you understand, and these type of questions will come in the next chapter. Here we have a wedge A, let me call it as A, and here we have a block B kept on the wedge. Now what is going to happen if it is a frictionless track? As soon as I leave this, they will start to move. Yes or no? Block A will start to move like this, and block B will start to move like this. Yes or no? Now, I want to study the motion of this block. I want to study the motion of this block. Now, there are two options for me to study the motion of this block. I can become the blue boy, stand on this wedge, and then watch the motion of this block. Or I can become the green boy, green Hulk, stand on ground, and then observe the motion of this block. How does the motion look like? For which boy does the motion look simpler? The blue boy or the green boy? How does the blue boy watch the motion? Remember, blue boy is on the wedge himself, and the wedge is moving towards right, and this block is moving downwards. So for him, how does the motion look like? For him, the only motion that he will see will be the block moving downwards along the incline. Yes or no? The motion will be pretty simple for him. But if we imagine the motion from this boy, the green boy, the motion is very complicated, because he will not just only see the block going like this, he will also see the wedge moving like this. From his reference frame, the motion will be very, very difficult. Do we understand this? The motion is not going to be simple from the green boy point of view, but the motion is going to be very simple if we see from the wedge itself. And that is why sometimes it becomes important for us to understand or study motion may not be from earth, but from different reference frame. And that is why this chapter is done separately under the heading of relative motion. Do we understand this? Yes or no? So here we are going to study the motion. Now if you want to study the motion, you might have to find out the position of the particle, the velocity of the particle, the acceleration of the particle. So how do you find the acceleration of the particle, or the motion, or the velocity of the particle? So here for this, we have some important points which are easily derived from vectors, that will help us in finding out the required things that we want to find out. For example, if I want to find out the position of this particle, of particle A with respect to particle B, body A with respect to body B. So how do I am going to do this? I am going to write it like this, and this is how it is done. Position vector of A with respect to G. Here G stands for what? Here G stands for your ground frame, minus, oh, I'm using the wrong color, minus the position vector of B with respect to ground frame. If you don't want to write this G, you can then simply write it as position vector of A minus position vector of B. This is the position vector of A with respect to B. When I say with respect to B, what it means that B is the observer, you have become B, B is the observer. How is the position of A if B becomes the observer? Do we understand this? Yes or no? Everyone in the class, please raise your hand if you understand this. I'll ask me. If you don't understand this, and it becomes difficult for you to understand anything else in the class. We understand this? So position vector of A with respect to B means if you become B, if B is the observer, what is the position of A? Similarly, you can find the velocity of A with respect to B. It can be the initial velocity of A with respect to B. It can be the final velocity of A with respect to B. It can be velocity at any time of A with respect to B. How will you find out the velocity of A, particle A with respect to B? How will you find out the velocity of particle A with respect to B? The formula is given right in front of your eyes. Just apply your brain and give me how will you get the velocity of A with respect to B? Whether it is initial velocity, whether it is final velocity, doesn't matter. Yes, how will you get it?
Velocity A minus velocity B.
So velocity of A with respect to ground, if you don't want to write ground, just forget ground. You can just write velocity of A minus velocity of B. How will you get the acceleration of particle A with respect to B? It will be acceleration of particle A minus acceleration of particle B. Do we understand this? I have not written G. If you want, you can write G. When I say VA, that is the velocity of A with respect to ground. Let me write it. When I say VB, I mean velocity of B with respect to ground. So remember that. I hope everyone is noting this. Now, since I know the relevant position vectors, I can also write the equations of motion, and remember this is only for uniform acceleration. Most of the question that you are going to find in relative velocity will be based on uniform acceleration. How will I find the, let me not write A, let me write it as 1. How will you find the final velocity of A with respect to B? Here V means final velocity of A with respect to B. Here, when I'm writing it at any point. If you want to find out the velocity of A with respect to B, you find the velocity of A and subtract the velocity of B. If I talk in terms of equations of motion, remember the equations of motion that we had written and we have been writing it many times. If I write the equation of motion, V is the final velocity and U is the initial velocity. How will I find the final velocity of A with respect to B if I know something else? How will I find it out? So I will find it out like this. Final velocity of A with respect to B will be equal to initial velocity of A with respect to B plus acceleration of A with respect to B into t. How did I derive this formula? This is the original formula just written in terms of A with respect to B. The first date when we wrote this formula, it was written as V is equal to U plus AT. There V was the final velocity of any particle. That final velocity of any particle was with respect to ground. Now I have just changed the reference frame and I am making it with respect to the particle B. Do we understand this? So this becomes the first equation of motion. What is the second equation of motion? Now you can tell me. What will be the second equation of motion? This is the first equation of motion written. What will be the second equation of motion written in terms of A and B? Yes? I'm not able to hear. Probably you are saying this. Displacement of A with respect to B will be equal to initial velocity of A with respect to B into t plus half times acceleration of A with respect to B into t square. This is what you were telling me, yes or no? That is the second equation. Yes, beta?
Yes, sir.
Okay. The third equation will look like a bit awkward, but I can't say. Final velocity of A with respect to B dot with initial velocity of A with final velocity of A with respect to B will be equal to initial velocity of A with respect to B dot with initial velocity of A with respect to B plus 2 times acceleration of A with respect to B dot displacement of A with respect to B. It looks very long, but I can't help you. This is the original way of writing it. Now, the fourth equation, which is the displacement in the nth second, you can also write it displacement in the nth second of A with respect to B will be initial velocity of A with respect to B plus acceleration of A with respect to B by 2 into 2n minus 1. These are the equations written in vector form. We may not be using the equation in the vector form, so we might use equation for x-axis and equation for y-axis. How will you write any equation? In general, to write any equation, I will just write it as v of A with respect to B is equal to u of A with respect to B plus acceleration of A with respect to B into t. But whenever we are writing the equation in this form, in the green form, we must do this with proper sign convention. Do we remember this? Yes or no? Can you write equation number
Yes,
2,
sir.
3, and 4 on your own? I'll give you 2 minutes. Note them down. Please let me know once you are done.
Answer.
Everyone got this?
Yes, sir.
Okay. Then I will straight away jump into a question. So this is the question that I have. See the figure, take the positive direction towards right and negative towards left. Find XBA. I hope you understand the meaning of XBA, XCA, XCB, XAB, and XAC. XBA means position of position of B with respect to A. XCA means position of C with respect to A, and so on. I will give you 2 minutes to note this down to solve this problem. Once you solve it, please let me know. Yes, bacha, no one able to do this? Shall I do it then? Shall I do it? I thought that it is simple. It looks like you are not able to do this. Okay, then I'll do it. Anyone got any answer?
Sir, P2A
Okay.
P2A minus 10.
B, okay. Let me find position of B with respect to A. So how will I do it? Position of B minus position of A. What is the position of B? This is the origin. Position of B is 4 minus position of A is 0. So position of B with respect to A is plus 4. Plus means positive in the right direction. Everyone got this? Yes or no?
Sir, I'm audible.
Yes, beta, you're audible.
Yes.
Everyone got this?
Yes, sir.
Then you can find out position of C with respect to A. C is at plus 10. A is at 0. So the answer is plus 10. Yes or no? Similarly, you can find position of C with respect to B. C is at plus 10 minus B is at plus 4. So it becomes plus 6. To find out the position of A with respect to B, you find out the position of A, subtract from the position of B, and what you will get? You will get minus 4. And then you can understand position of A with respect to B is minus 4, whereas position of B with respect to A is plus 4. They are reverse of each other. So you can write, understand, and think position vector of A with respect to B will be negative of position vector of B with respect to A. Yes or no? You understand this, everyone? Whether you talk about velocity of A with respect to B, it will be negative of velocity of B with respect to A. If you talk about the acceleration of A with respect to B, it will be negative of acceleration of B with respect to A. They are negative vectors of each other, same in magnitude but opposite in direction. Everyone understands this? Yes or no? Shall we move ahead in life? Okay, so this was a very simple example. This was finding out the position. Remember, questions are all very simple. First, we will try to do questions of motion in one dimension. Then very quietly, we will move into 2 dimension. You will see that nothing has changed. Equations are same. The only thing is you probably have to make equation in 2 directions. This is the next question. Question number 2. Object A is moving with a velocity of 5 meters per second and B is moving with 20 meter per second in the same direction. The direction is given as positive x-axis. You have to find out velocities of b with respect to a, velocity of a with respect to b. I'll give you 2 minutes to do it. Got the answer, bacha? Can't hear you properly, but I suppose that you would have got the correct answer. Let us wait for all of the students in all class. I think I have answers. Yes, bacha, tell me.
Sir, first one is plus 15. Second one is minus 15.
First one is plus 15 and the second one is minus 15. All of you got this answer? Well done. It is very simple. If I take this direction as positive, I can write velocity of A with respect to ground as plus 5. I can write velocity of B with respect to ground as plus 20. If I have to find out the velocity of A with respect to B, I can call it as plus 5 minus plus 20, and your answer will be minus 15. As soon as you get the velocity of A with respect to B as minus 15, you don't have to find out the velocity of B with you don't have to find out the velocity of B with respect to A. The velocity of B with respect to A will be negative of this. That would be plus 15. Everyone got this? Yes or no? No, yes. So it is pretty simple this way. Let me give you the next one. Shall I? Remember, this relative velocity is pretty simple. And once you get the hang of it, you will find out it becomes very easy to solve this question using relative velocity. This is the next one. Question number 3. 2 minutes you have. Two objects A and B are moving towards each other with velocity 10 and 12. Find A with respect to B and B with respect to A velocities. Everyone got this? It's pretty simple, I think.
First one minus 2, second one 2.
Minus 2? Minus 2? How did you get minus 2? No, 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 my dear friend. Think again, think again, think again.
First one 22, sir.
Yeah, think again. Don't answer in haste.
Minus 2.
Yes. Don't give your answers in haste. In a haste, sometime we might miss the point. So take your time and give the answer. In first case, the answer is plus 22, I think. And the second case, the answer is minus 22. Yes or no?
Yes, sir. Yes, sir.
Everyone got this?
Yes, sir.
Okay. Now, if I ask you in the same question, if I ask you something, if the distance between them, when this photo was taken, if the distance between them was, let us say, 110 meters, if the distance between them was 110 meters, when will they meet? Distance is 110 meters. When do they meet? When and where? First, let us find out when, and then we will find out where. When and where do they meet? I'll give you 2 minutes to think about this again.
Bicycle, sir.
They will move. They will meet after 5 seconds. Correct. Now, if I ask you, where do they meet? Where do they meet? If I say that this is the origin is where A was initially, where do they meet?
50 meters, sir.
They will meet at a distance of 50 meters from A. Well done. How did we do this? How did you do this? So now, whenever you encounter these questions, obviously these questions can be done from the reference frame of Earth. For example, if I had to do this question from the reference frame of Earth, what I would have done, let me take everything out. What I would have done is, one way of doing it, I would have assumed that this moves a distance x, then this will move a distance 110 minus x, because the total distance is 110. Whatever time body A takes to move from A to B, if I call that time as t, the same time body B will take to move from B to this point. Let me call this point as C. Then I will make equation for body A. Then I will make equation for body B. From there, I can get the value of T, and I will get the value of T as 5 seconds. Not a problem. But this question can be very easily done with the concept of relative velocity. How it can be very easily done with the concept of relative velocity? Now let me finish the diagram here. What do I do is, I decide that let me become any one of the bodies. So you can either become one, A, or you can become B. I have decided to become, let us say, B. I have decided to become B. Now, as soon as you become body B, remember, you will see everything with respect to B. Do we understand this? Yes or no? You will see everything with respect to B. And as soon as you become B, remember and understand that B is not moving now. Everything else is moving around you, but B is not moving. So first of all, I have to find out how much is the, let me take this direction as positive, how much is the initial velocity of A with respect to B. We have already found it out. Yes or no? Initial velocity of A with respect to B. A is moving with plus 10, minus B is moving with minus 12. So the relative velocity of A with respect to B is 22 meter per second. Do we understand this? Yes or no? As you can see, there is no acceleration of A with respect to B because they are moving with constant velocity. Yes or no? Yes or no? Then I write what is the displacement of A with respect to B. Remember, B is not going anywhere. So B is not going anywhere. B is standing at this position. A has to come. How much A has to come? A has to come from this position to this position. How much will it move? It will move a distance of plus 110 meters. Yes or no? It will move a distance of plus 110 meters. Now you can apply. There is no acceleration. So this question becomes very simple. There is no acceleration. The total displacement is plus 110. The velocity is plus 22. Displacement divided by velocity, because as soon as I apply this formula, displacement of A with respect to B is equal to initial velocity of A with respect to B into T plus half acceleration of A with respect to B into T square. I understand that this part is already zero. Yes or no? So I can straight away get the time as displacement, which is plus 110 divided by the initial velocity, which is plus 22. And I straight away get the time as 5 seconds. They will meet after 5 seconds. We understand this, all of us? Yes or no? Yes or no? Okay. As soon as we know that they will meet after 5 seconds, where they will meet, then what do? You make the equation of any of the body with respect to ground. How much will be the displacement of A with respect to ground? That will be initial velocity of A with respect to ground, which is plus 10 multiplied by 5 plus half AT square. There is no acceleration of this body. So this will become 0. So where they will meet? The answer is simply plus 50 meters. Do we understand how I have done this and how quickly I could do this with the concept of relative velocity? Yes or no? Do we understand this, everyone? I'll give you 2 minutes to note this down. Has everyone noted this down? Shall we move ahead? Then comes this question, a pretty simple one, and I'm sure you will be able to solve it and give me the answer quickly. A particle A is moving with a speed of 10 meter per second towards right. Particle B is also moving with a speed of 10 meter per second towards right. Another particle C is moving with a speed of 10 meter per second towards left. The separation between A and B is 100 meters. Find the time interval between C meeting B and C meeting A. So basically, C has just crossed B. Basically, they are asking us after how much time C will cross A. And it's a very simple question. And if you understand the concept of relative velocity, the question can be done very simply. I'll give you 2 minutes to solve this. And if you look closely, this question is exactly same as what we had done just now.
Zero. C
Zero.
meeting B is 0. C meeting A is 5.
5 seconds. Yes, that is correct. 5 seconds. Everyone got the answer, 5 seconds. So as you can see, it is pretty simple. Basically, they're asking you when is A and C going to meet. A is here, C is here. You can become C. You can become C. You can find out velocity of A with respect to C. That will be plus 10. This is the positive direction. So the velocity of C becomes negative. Everyone is getting my point, yes or no? So minus of minus 10, the velocity becomes plus 20. If I look at the displacement of A with respect to C, C is not going anywhere. A is coming, A has to move plus 100 meter. How much time he will take? 100 divided by 20, that is 5 seconds. Remember, acceleration of A with respect to C is 0. Everyone got this? Yes or no? Can I have raise hands from everyone? Okay. Now comes this one.
Right, sir.
You are noting it down? Okay, I'll give you time. Note it down. Let me know once you're done with it.
Yes, sir.
Shall we move?
Yes, sir.
Okay, then this is the next problem, and I hope you can give me the answer to this one. A and B are thrown vertically with velocity 5 and 10 meter per second respectively. The value of G is given as 10 meter per second square. Find the separation between them after 1 second. I hope you can see the question. They're on your screen now. A and B are two. Now remember, up till now, things were moving on road. Now it is thrown under gravity. Both A and B are moving under gravity, my dear friends. To find the separation between A and B after 1 second, I'll give you 2 minutes to solve this. Remember, we don't have to do anything new. We just have to do things simply. Shall I help you?
Hi.
5 meter. How did you get it? Yes, that is the correct answer. 5 meter per 5 meter. How did you get it? Tell me.
UT minus half GT square.
Okay, so again we do the same thing. Let me write velocity of A as plus 5. That is the initial velocity of A. Initial velocity of B is plus 10. Okay. Now we can do this question from the ground frame, or we can do this question from the frame of reference of B. So I can write the initial velocity of A with respect to B will be minus 5. Yes or no? Plus 5 minus plus 10, it will be minus 5. Now the good thing about here is, if you look at the acceleration of A, it is minus 10. If you look at the acceleration of B, it is also minus 10. In fact, if you find out the acceleration of A with respect to B, it will be 0. And that is a very important point that you must remember. These two are projectiles thrown up in air. The acceleration of one body with respect to the other body, the acceleration of one body with respect to the other body is 0, because both are moving under gravity, both have the same acceleration. Do we understand this, everyone? Boys, do we understand this? That the acceleration of A with respect to B or B with respect to A is 0. I just have to find out the displacement. So what is the displacement of A with respect to B? That will be equal to minus 5, the initial velocity multiplied by time, plus half AT square. A with respect to B, that is 0. It is coming as minus 5. Why it is coming as minus 5? Because B is above A, B is above, and A is below. That is why the answer is coming as minus 5. Do we understand this? Yes or no? Well done. We are moving very swiftly. Let me put this question in a different way. And this is how the question looks like in a different way. Everyone has noted this down? Then I move on to the next question, and probably I will give this question as a homework, because I think time has already run out for this class. This is the question. Question number 4. A ball is thrown vertically downwards with a speed of 20 meters per second from the top of a building 150 meters high. Simultaneously, means at the same time, another ball is thrown upwards with a speed of 30 meters per second from the foot of the building. Find the time when the two balls meet. The value of G, acceleration due to gravity, is given as 10 meter per second square. So I'll give you this question as a homework. I hope you try it. We'll come and do many more problems on this relative motion. I hope this relative motion, you are feeling comfortable with the topic, yes or no? And you will understand, the more the number of questions you do, you will find that relative motion, doing question by relative motion is a lot simpler than by doing question from the ground frame. And that is why we are studying the motion of one body with respect to the other body. I will wind up this class here.
30 seconds.
Yes, beta? 3 seconds, you said?
Yes, sir.
3 seconds is the answer, beta. Well done. You see, you have given me the answer so quickly. Well done. I have already sent you the sheet for this. I hope you are trying questions from that sheet. 3 seconds is the answer. We will discuss it in the next class. If you understand the concept, nothing like it. Well done. See you in the next class. Take care. Have a nice day. Any problems?
Sir, wait, sir.
You can always ask me. Yes, beta.